Good evening. Good evening once again, guys. Good evening. Am I audible? Hello? Am I audible to you?
Yes, sir.
Okay, so let's get started. Fine. So, in the last session, we just started over with HAP software, and I think I just explained some kind of uh, topic regarding the HAP itself. Especially, we started over with the weather and conveniently we hopped over to the schedule creation right inside the internals, isn't it? That's what we started over with the last session. So I'm gonna continue that itself. Okay, so yesterday I think we completed till this walls and windows. So you can see right here itself I entered the whole values, especially for the corresponding exposure, which means for each and every exposure I entered the proper values, especially the wall area and similarly the glass areas. Okay, then you can see on this window quantity, I've been entered the number of windows that I'm having on each exposure. Okay, why? Because on this tab, you are actually created a window type. So in window one, which means this window one will have a length and height, which can be deliberately taken from the CAD itself, which means from the shop drawing itself. Later, I explained about the roofs and skylights, and especially I've been intimidated. It has to be the infiltration. So this infiltration step is normally neglected. Why? Because we don't know the exact value, or we can't predict the amount of air which should be entered right inside to my space whenever the fan, which means the machine, sorry, the equipment fan is turned off. And similarly, whenever you open the doors, we can't predict how much amount of air should enter into that corresponding space. It's an forbidden value, isn't it? Or like an unpredictable value. That's it. Later, it's about the floor. Okay. So here you can see it's actually defining about the whether there is a floor load is there or not. That's what they are actually depicting right inside this tab right here itself. Okay. So on this theorem project, they already provided the data. It has to be the floor name is ground floor, and especially there is no floor below to that current floor itself, which means it is directly attached to earth itself. So in those scenarios, we know that if the floor is directly attached to the earth, then it should be, or probably the floor load should be nearly zero, isn't it? And similarly, this is the same consideration that we can imply. For example, when a floor is placed above an conditioned space, which means your floor is placed on top of an AC space. That means there won't be any heat transfer through your floor. Or in other words, then only, beg your pardon, then also you will be having or you will not be having any floor loads from that floor itself. Why? Because the bottom floor is already provided with some kind of air conditioning. So there won't be any kind of heat transfer through the floor that you having right on the area itself. So technically, these both ideas are much more similar, isn't it? When the floor is connected to earth or when the floor is placed on top of an AC space, in both scenarios, the floor load is zero. So that's why here we are considering the floor above conditioned space, which means our floor is placed above and conditioned space. That means, again, the floor load is zero. That's it. Later, it's about floor above unconditioned space. So in these eyes, actually, they are depicting the other condition, which meant to be you having floor loads. For example, on bottom of your floor, the other space at the below of your floor should be probably a non-AC space. So what are the things that we need to consider? Initially, the floor area, then the U factor for the floor, and the other values starts to be the unconditioned space max temperature, ambient at max temperature, unconditioned space minimum temperature, ambient at space minimum temperature. So these are the things that you need to take out from the respective area itself. Okay, So this factor which implies about the actual flow load concepts. Okay. Then once again, you can see the other factor or other indices which is mentioned as to be slab floor on grade. So this slab floor on grade, which also implies that your floor is connected to a normal foundation itself, which is meant to be connected to earth itself. Okay, so grade, which means the concrete foundations that you will be normally providing, or maybe the earth. That's what you mean by a grade. So technically, why we are considering, why we need to include this right inside the floor data itself? Why? Because as I mentioned before, the HAP software is not only to find out the cooling load or heat load. It is also used in whole application itself, which means if you are implementing heating, then we need to know that how much amount of actual cold energy is right inside the area itself, isn't it? So when the floor is directly attached to the earth, probably in colder regions, which I'm mentioning these Western countries, while they are taking or while they are implementing an heating mission, suppose if they doesn't consider the floor load, what will happen? The machine should, uh, the machine can't be eradicate the energy comes out from the floor itself, isn't it? So that's why here we are considering slab floor on grade. Okay. Again, you can see this now. Floor area, total floor U value, exposed perimeter, and the edge insulation R value, which is the floor insulations that they will be providing on the Western countries. Probably that should be wooden floors, isn't it? You've been seeing that scenarios. So, however, this is the concept behind the slab floor on grade. And the other one you can see slab floor below grade. So this means technically a basement concept. Okay, that means below your floor, you will be having some kind of series of basements. We can see this now, floor area. Once again, that should be same as per your uh, actual area itself, which is meant to be the 2022 square feet. Then the floor depth, basement wall, U value, wall insulation, and depth of wall insulation. So these are all meant to be the basement concept itself. Clear? So in here or in this project, we can simply go with floor above condition space. Why? Because here the floor load is zero. That's why. Okay. So is it clear, guys? Okay now. Is the concept is clear? Okay, Le. Hello. Is it good? Good to go. Tell me, guys. I need to move on with the other one. Okay, fine. So this is the uh, data about or data that we need to know about the flows. Next of all, it's about partition. So in this partitions, you can actually encounter two type of partitions are there, which is ceiling partition and wall partition. So what do you mean by ceiling partition? Ceiling partition is nothing but that is meant to be the ceiling load. They are actually portraying the ceiling load right inside the area. Okay. But in this project, once again, here they mentioned that floor above is first floor, which is already provided with an air conditioning system itself. That means we don't need to consider any ceiling loads right inside the project. That's it. Later, it's about the wall partition. Actually, here we having wall partitions, isn't it? How you need to, how we can find out the wall partitions right inside the area that is meant to be this wall and respectively this one. Later, it's about this area. All right. So this is it. It's total. We can see 26 plus 16. That means 26 plus 16. That should be around like 30, 30 sorry, 42 something. 42. Yeah, 42. Then 42 plus 13. 42 plus 13. That should be 55 and 55 plus 29. 50 plus 25. What is it? 55 plus 29. That should be 84, doesn't it? So 84 feet is the total length, and just consider this also. 8 plus that should be that means 15 feet, 15 inches extra, isn't it? Like 6 inches plus 18 inches plus 1, 8 inches plus 1 inches. That means 15 inches around, like, isn't it? Yeah. 15 inches. So that means we need to add 1 feet extra. So that means, from this function to 84 plus 1 feet, that is 85 feet, and 85 point remaining, that should be probably 3 inches. So that means use this equation, calendar 85.3 into DOS, that is 12 feet. So you'll be getting around like 1023, isn't it? 1023 square feet. So this is the total partition wall area. So that's what I mentioned right here also. You can see this now, the total area. Then it's about the U factor. Generally, the U factor of partition wall is considered around like 0.30 itself. Okay. Generally, the uh, U factor for partition walls are considered as to be 0.30 itself. Okay, that's it. So now I'm just going to a small recall that what we done in the last few tabs. So the first one, it's about the general tab. In this tab, actually, we need to dedicate our area according to the floor areas, which means I told you right in that topic itself. Why? Because here you having different kind of cabins. So if you are considering it has to be a different area, then you need to provide the names and the areas should be different. But here I told you once again, I'm considering this entire project has to be an entirety, isn't it? So that's why I've been named it has to be the full name. There is a theorem and the total area and the ceiling heights and building weight is normally 70 pounds per square feet. And it's about the FACFM data. So here I'm not entered the value as to be an user defined method. Instead of that, I've been entered like in a computerized way, which means according to the standards, I've been choose the value. So for that one, I choose the office concept, which is especially telephone and data entry. That means a light or medium work should be happening right inside the area. Later, it's about the internals, especially lighting loads, electrical equipments, people. So among these, each and every factors, you might need to create the schedules. That means how this office is actually working. Later, it's about the walls and windows. So in this walls and windows, I told you initially you need to start with the wall creation, and later here you need to mention the wall gross area according to each and every exposure, and laterly you can enter the window quantity. For that one, you need to initially create a window. Later, afterwards, we just studied about the roofs and skylights. So if you're having roofs, either you can click on to horizontal option or you can click on to northern, which means according to the exposure side. So if you placing or choosing it has to be an exposure method, obviously it will ask for some kind of slope value. Okay. Then after that, it's about skylights. So skylight is a kind of glass itself. So we need to mention the dimensions of that skylight. Then automatically you can enter the quantity of skylights right to there itself. And infiltration, it's a negligible. I told you right now itself, and it's about the floor conditions. So wisely choose the options from this according to the project itself. And later it's about the partitions. Here you're only having wall partitions. Okay. So it's about the other thing, guys, which is unconditioned space max temperature. That is meant to be the other side temperature, other side minimum temperature. That's it. Whatever. So this is the concept that we need to done or do right inside the space tab. Okay. So this is the space properties. All right. I hope it's clear. Once it's done, just click on to this OK option. Later, go on to the last but at least the main thing, which is the systems. So among the systems, we can see, just double tap on this one. Here you can see actually this is a saved file. That's why you can see the name right here itself. Normally it should be mentioned as to be the enter a name, something like a default name or a default system, whatever will be there. Okay. So here you can mention any names. So for example, I'm going to mention it has to be a theorem AC. That's it. Okay. Then on the other end eyes, it's actually defining about the equipment. So here you can see packaged rooftop units, packaged vertical units, and split air handling units, chilled water air handling units, terminal units. So technically here we need to uh, choose the mission. But actually, guys, we don't know that capacity, we don't know the DCFM. So how we are going to choose the mission? Here is the thing. Here we are using HAP software to only find out the capacity and the CFM value itself, not the mission, isn't it? So let it be undefined. Okay, clear. Then later you can see on to this option, air system type. So here you can see CAV single zone, CAV terminal reheat, and VAV and VVT. So this VAV and VVT is which much similar. VAV implies variable air volume and VVT implies variable volume temperature. CAV implies constant air volume. So I almost explained that it has to be. Here we are considering this entire has to be a single zone itself, isn't it? That means it should be considered like a constant air volume method itself. We know that, however, here the airflow shouldn't be equal for each spaces. That should be different according to the area that I know. But however, initially I need to know that how much amount of air should be required, doesn't it? So that's why here I'm considering it has to be a single zone. Okay, that means we need to go over with CAV. Suppose if you're choosing VAV, we can see actually you can edit the number of zones, which means for that one, you need to create multiple spaces. That I told you that itself now, which means manager cabin 1, zone 1, manager cabin 2, zone 2. So similarly, you need to create multiple space with the whole other options, especially the internals and the walls, windows. So these whole kind of things should be entered manually right inside the space tab. Okay. But I told you here, I'm considering it has to be an entirety itself. That's why I consider the spaces also has to be an entirety. That means here we are going with CAV with a single zone assembly itself. Clear? So I hope you understand that how we end up on the CAV systems itself. All right. Later, it's about the system components. So among the system components, you can see a lot of things. It has to be ventilation, air economizer, ventilation, pre-clean coil, pre-cool coil, pre-coil, humidification, dehumidification, central cooling, heating, fan, duct system, return fan. So a lot of options are there, isn't it? So in this one, actually the first, you don't need to enter the entire values here. Why? Because it's all about the machine spec. Actually, we don't know the machine spec. But however, you might need to enter some kind of a little bit known values. For example, damper position, pardon, damper leak rates. Generally, inside your duct system, maybe you'll be having some kind of dampers. That should be a mandatory thing. They will be there. So generally, if the damper is in the closed position, then probably some kind of leakage of air will be there. That is an, that we can't be eradicated from that system itself. However, that should be there. So that's why I entered the value has to be 10%. Once again, guys, it is not a mandatory thing. If you know the value, just enter this value. I told you, generally, we can consider up to 10% or maybe beyond that itself. It's according to the project itself. But here, I'm just going with 10% only. So you may might wonder where we got this 10% damper leak rate. I told you it's not a constant value. Either you can enter the value or let it be blank itself. There is nothing will going to happen to your output. Later, it's about the central cooling. No other things are important. On this one, you can see the coil bypass factor, 0.15. That we know or that we studied that 15% is the coil bypass factor. That's it. Then don't change the supply temperature right here itself. All right. So later it's about the supply fan, nothing to enter right inside the supply fan and duct system. So if you are implementing duct system, then you need to provide some kind of ideas like this way. For example, supply duct data. If you are installing a duct system, probably a 10% of heat gain will be there at the same time, a 10% of duct leakage will be there. So this is how we are going to consider the supply duct data. Clear? Simply, the heat gains are considered like 10% and leakage is also considered as to be 10% itself. Later, it's about return air data. So we studied that there are two different methods that we can terminate our return air, either through the plenum area or through return duct itself. Suppose if you are using ducted return, then you don't need to enter any kind of values. But suppose you are using a return air plenum, then you need to mention these values. It's very simple, guys. I told you that Q supply is equal to Q return. That means 100% of supply, which means 100% of return. That's what is the expected output that we need to sorry, it's not an output. Actually, the 100% supply means 100% return air. Or in other words, the same air entering to the room should be gone to be again traveled across to the evaporator coil for the next round, isn't it? So that's what I'm simply meant to be right here itself. So while this return air is going through this plenum area, the temperature of the return air can rise due to some various aspects. It has to be, you can see wall heat gain. So I'm going to consider it as to be a 20%. If you're having roofs, you can consider it as to be 30. Pardon, you can consider it to be 50. Okay. Then lighting gains. Lighting gain, I'm considering it as a 20. Okay. So just ensure that the while adding the center values, if you got 100, then it should be okay. Clear? That means while adding this each and every values, we need to get 100. So wisely choose the option values for especially for the wall, roof, and lightings. So once the system components is entered,
The
later
return
it's a,
is 85 or 100.
sorry, which one?
Return is 80 or 100.
It's
Return
30,
error.
50, 20.
15% will be bypass now.
No, nothing like that.
Okay,
Yeah. I told you here just
okay, sir.
once again. Here, actually, we know that if I'm providing my return air through plenum, rather than through this room return air, there is a slight variation of temperature will happen due to the wall heat gains, roof heat gains, light heat gains, isn't it? I told you about the yesterday about the lighting loads, isn't it? Like unvented lights and vented lights. So in those scenarios, we will be having some kind of extra temperature through the return air itself. So how we are getting extra temperature? By the wall heat gains, maybe through the roof heat gains, or either through the light heat gains. Okay, so that's what we are actually mentioning right inside these columns. Okay, it's not about the bypass factor or anything else. This is the one that you are asking about, I hope. The ventilation air, you can see, not this one. In supply, in central cooling, you can see this now. This is what you're actually asking for. Coil bypass factor, which is 0.15. Okay. That should be there. Suppose if it is in 0.100, like in 1.0, 0.10, then make it as to be 0.15. That's what you need to do. So once you enter the whole values, which is the known values. Once again, guys, note it down. Once you enter the whole known values, then you can skip on to the zone components. So inside the zone components, actually you need to do the same simple thing. Here we can see the spaces. I told you in this project, I considered theorem as to be an entirety itself. That means that's why here you can see theorem only. Suppose if you consider manager, cabin, office area, reception area, utility room, waiting halls. So like this, likewise, what will happen? Different spaces will be there. So initially, we need to add these spaces for the upcoming calculation. For that one, just click onto the space and make it as to be add. So it should be automatically updated for this. Okay, clear. And once again, guys, you can see right here itself, zone 1 out of 1, which is meant to be, I told you, is a single zone, as a single zone project. That's what we are actually doing right here itself, isn't it? Later, it's about the thermostats. So what do you mean by thermostat data? Thermostat, which means it is an kind of temperature sensor or something, which enables or which makes the cutoff temperature, isn't it? Or which determines, pardon, which allocates the cutoff temperature in each rooms. So whatever, here you can see all zone thermostat set the same. If you untick this option, you can see that means we can actually set the set points for each zones. For example, here you can see now in manager cabin 1, if the manager cabin 1 reaches 24 degrees Celsius or even 23 degrees Celsius, they should the airflow need to cut off from that area itself. So these idea actually implying about the VAV system. It's not meant to CAV system. Okay. So that's where once again, I'm pinpointing that point itself. So here, actually, if you are considered like that way, then you can assign for each zone temperature, which is the set point temperatures. But here we know we are considering it has to be a single zone. That's why all zone thermostats set the same. That's what I meant. That's what I'm making it has to be like this way. Then here, if you are opening it freshly, here you can see 75 and here you can see 80. Okay, so just make this one at occupied, it should be 73 and unoccupied, it should be 75, which means if the temperature reaches 73 Fahrenheit, it is meant to be around like 22 point something, you need to cut off the temperature or cut off the airflow to that area itself. Again, if the room temperature reaches 75 Fahrenheit, which is around like 25 something, then you need to turn on the airflow or allow the airflow again into that area itself, specific zone itself. So this is the concept behind this one. But however, I told you, we are considered it has to be a single zone itself. That's it. Later, it's about the thermostat schedule. Click onto the thermostat schedule. So it's meant to be the machine schedule. That means how this equipment is going to work on right inside the place. So this is nothing but this is the same schedule that you need to provide, which should be done for the internals also, which means how this machine is going to turn on according to the company time. That's it. Here you can see I mentioned has to be work days. I told you at 9 o'clock is my office is going to work, isn't it? So here I mentioned has to be 9 o'clock, isn't it? 9 o'clock. So you can see right here itself. At 8 o'clock, some amount of persons will be there. That means a part load. But there is no much space for that. There is no much space for this ideas. It has to be part load, full load. Here, it's about the equipment. That means occupied or unoccupied. That's it. If the machine is on, that means occupied. That's it. That's why here I mentioned it has to be 8 o'clock has to be occupied stage itself. And actually, this is a project that are already done in previous sessions itself. That's why here you can see this is 10 o'clock and this is 11 o'clock. I consider it till 9 o'clock. My office is working till 8 o'clock and the 9 o'clock is the leaving time. So that's why I consider like this way. Later, it's about the Sundays and holidays. That means to the second profile. In second profile, the machine will not be running for the other extra times, isn't it? That means purely here there will not be any loads. So you can make it as to be 0 in the entirety. Okay, that means full unoccupied. Once it's done, assign the profiles according to the days. That means the first profile should be from Monday to Saturday, and the second profile should for Sundays and holidays. That's it. Once it's done, just click OK. Now our thermostat schedule is updated. Okay. Once it's done, next of all, it's about the supply terminals. Here, we don't need to do any kind of data. Why? Because this is the thing that we are actually going to find out. Here you can see minimum airflow, which you need to provide. You can see CFM per person. I told you these values are already preset by the HAP software itself. So we don't need to enter the values manually once again. If you having any doubts, just make it has to be 15 CFM. Why? Because here they provided, isn't it? 15 CFM per person. So if you need any clarification, we can enter the value 15 CFM and check the output and clear the value. And once again, check the output. There will not be a great difference. Okay, a slight difference will be there. That's it. So once it's done, here I told you guys among this air system properties, you don't need to enter whole data. You just need to mention the important factor. That's it. Later, it's about the sizing data. So in sizing data, here, especially on the safety factors, you need to mention the sensible safety factor, which is 10%, and latent is 5%. That we already done in the heat load session, isn't it? You remember the factor of safety for sensible load and factor of safety for latent load. That's we done, isn't it? So that should be 10% and 5%. And you can mention a 10% for heating also. That's an optional thing. If you provide it, that's not a problem. So always make it has to be computer generated. Okay. I told you I already taken output. That's why here you can see the value. Otherwise, it should be blank itself. If you put user defined, that means you can actually set the cooling supply temperature and what should be the minimum ventilation airflow required for the, that means you can see this now, the actual airflow rate should be required for that area. So these values can be manually entered, but this is not the flow. I told you we should go with the computer generated method itself. Later, it's about the zone sizing. So you can see for zone 1, I told you once again, guys, here we already considered it has to be a single zone itself. That's why here you can see only one zone. If you consider multiple zones, then you will be having multiple zones like zone 2, zone 3. So for each zones, you will be getting a probable supply airflow value right here itself. If you make it has to be user defined, you can actually edit the value right here itself. But I told you we should go with the computer generated method itself. So at last, you can get on to the equipment tab. On this equipment tab, you can see no equipment data required for the system. Why? Because here initially I didn't consider any kind of equipments. That's why here you will be blanked out with this kind of notation itself. Okay. So symbolically, the important things initially start with the naming, and it's about the system components, especially ventilation, air, cooling, and duct system. That needs to be the return airplane. Okay. Later, it's about zone components. Especially, you need to go with the thermostat schedules, especially the set points, temperature, and the thermostat schedule. And similarly, later it's about nothing but least. The main important thing is the thermostat schedule. That's it. Add these spaces At last, the sizing data, especially for system sizing, just enter the safety factors, and zone sizing, nothing to do, just leave it blank itself. Then click OK. So once you enter this value, now we are going to take out the output of this HAP software. Okay, now we are going to take out the output of the software. So how to take the output of the software? That's what we are going to peep out. Okay, so till this, is it clear? Hello? Till this, is it clear, guys? Like the system and the spacers, these in this size is clear. Is there any doubts on the
Sir,
systems? Yeah. Okay or no?
in the spaces, I have a doubt.
Spaces? Yeah.
കേൾക്കാമോ സർ?
ആ
Can you hear
കേൾക്കാം.
me?
പറഞ്ഞോളൂ.
സ്പേസസില് തിയറം എന്നുള്ളത് ഒറ്റ പ്രോജക്റ്റ് ആയിട്ട് ഒറ്റ സ്പേസ് ആയിട്ട് നമ്മൾ എടുത്തു. അപ്പൊ ഡിഫറൻസ് ഓൺ ആയിട്ട് വരുമ്പോൾ അത് എങ്ങനെയാണ് നമ്മൾ ആഡ് ചെയ്യുന്നത്? ഈ ന്യൂ
അത്
ഡിഫോൾട്ട്
ഒന്നുമില്ല,
സ്പേസിൽ
നിങ്ങൾ
ഓരോന്നും ആഡ് ചെയ്യുവാണോ?
you can see right itself. Double tap it again. You can create another space. Okay.
ഓക്കെ
അത്ര അത് ഞാൻ
ഓക്കെ, അത്
പറഞ്ഞത് ആദ്യം
വെച്ചിട്ട് ബാക്കി എല്ലാ ഡീറ്റെയിൽസും കൊടുക്കാം.
അതുപോലെ തന്നെ അതന്നെ. അതായത് ഫോർ എക്സാമ്പിൾ, if you are considering only manager cabin one has to be a single zone, then only you'll be having a northern wall. There is no partition wall for the side ones. Okay. And but this should be the partition wall, and you don't need to consider these walls. Okay. Don't need to consider, but you need to consider the area. Area എന്ന് പറയുമ്പോൾ ഇത് എടുക്കണം, മനസ്സിലായോ? ഏരിയ എന്ന് പറയുമ്പോൾ ഈ റെക്ടാംഗിൾ എടുക്കണം. പക്ഷേ വാൾ എന്ന് പറയുമ്പോൾ നിങ്ങൾ ഈ പാർട്ടീഷൻ വാൾ ഇത് എടുക്കണ്ട, ഈ പോർഷൻ എടുക്കണ്ട, പക്ഷെ ഈ പോർഷൻ എടുക്കണം. Then we can see the systems lightings that should be common. Okay. Similarly, you need to do the same thing for other areas like chairman cabin, this office area, and this reception and meeting area, discussion room, utility room. So how much spaces you are creating, that much zones will be appear. Okay. Clear?
Okay. So by using new default space, we can add up
create
also.
multiple. Yeah, you can create multiple spaces. And similarly, you can apply to the systems also. Then you can see, now I'm going to taking the output. Just right click this option. You can see print or view design results. Click onto this option. Then enable the entire things, which is meant to be the system sizing summary, zone sizing summary, ventilation sizing summary, hourly zone loads, hourly system loads. Especially if you need some graphs for supporting, you can enable the graphs also. And you can see the time specification that should be from July, which is the peak temperatures. Okay, that's why like June, July, March, April, May, June, July, this is the peak temperatures that we need to consider, like the summer season. That's it. Once it's done, just click onto the preview option. Then you can see the actual coil load. So you can see this now. This is the exact output that we need to forward to your client itself. Especially, you can see the air system name and the number of zones, the floor area, location, and total coil load, 7.410. And MBH is another unit of BTU per hour itself. So don't need to worry about that stuff. And you can see the coil loads. So you can see coil CFM at June 4 p.m. 16, which means 4 p.m. That is around like 4,728 CFM. But if you can peek onto this option, you can see this now standard CFM. That is only around like 4,234 CFM itself. Okay, that means 4,234. That means that is the actual CFM that we'll be requiring for that area itself. And you remember in Excel sheet, we've been done this small point, which is CFM per square feet, dividing the entire CFM with the area. That's what they done right here itself. Then if you scroll down to this option, we can see a lot of things, especially you can see this in zone 1. Maximum design airflow, that should be 4,255. Then time of peak load, June. Okay. Then similarly, you can go into the other options like this wall transmission. You can see this now. Actually, they already excluded the wall areas. They considered the total wall transmissions, especially for each and every areas, the latent loads. You can see this now, only we having the latent loads, like latent people, isn't it? That is 10,000 something, latent load something will be there. Okay, clear? Okay, that is about 50%. That's where we got. Then it's about later we can scroll on to the downside option. It's about the wall load. Once again, it's showing the same thing, guys. You can see this now, overhead lighting. Then the safety factors that they've been considered according to each and every loads. Then at the end of this, you can see for each and everything, they've been entered the value. You can see this now, wall, windows. I told you, they will automatically exclude the window area from the wall gross area itself. Later, it's about the maximum loads, which mean to be the heat, pardon, the cooling coil temperatures and cooling coil loads should be required at each hours. You can see uh, the outside temperature and the supply airflow CFM. We can see at 12 o'clock, actually, we only need 1353. That means less or no volume of air. But at 12 o'clock, that you can see this now. This is the maximum temperature that will be maximum airflow that will be requiring 4728 CFM. Okay, and similarly, we can take a lot of values. For example, at the end of the data, end of this report, you can collect this kind of psychrometric charts, especially mentioning this one. You can see this now. The actual design cooling according to each and everything's outdoor air quantities, and that means temperature and humidity ratio. That's what they are mentioning on each specific data. For example, duct heat, room air, central cooling coil outlet. It is meant to be, guys. It's nothing but don't need to worry about these kind of things. We can directly forward to the client itself. It's about the data according to temperature to HR value. HR, which means humidity ratio. That's it. Okay. And similarly, the zone loads. You can see this now hour of day, and you can see it start from. You can see this now. Actually, this is nothing but it's about the office timing. That's how this graph is going upwards, isn't it? So this is the concept behind this HAP output. Once it's done, just click onto this print option. We can take out a print itself. Save and print option. Okay. Is it clear? So is the HAP software is clear, guys? Let's go once again with the HAP software. So once it's done, that's it. That's all about the HAP itself. So once again, guys, any small doubts regarding with this outputs or any other aspects such as like systems or space? No, isn't it? I hope it's good. Okay. So is it clear, guys? Okay now. Hello?
Yes, sir.
Okay,
Yes,
fine.
it's clear.
Okay. So uh so can I jump to the next topic, or you are going to practice it? What is I going to do? Can I go to next topic? Hello? Tell me, guys, can I wind up the session, or can we continue with the next topic? That's what I'm asking. Next
We
topic
will
is
wind up.
actually
Wind up, sir.
wind up. Okay. Next topic is, so I will give a small interface about the next topic. Next topic we are going. So I will make a small recall what we done. So from the starting of the HVAC, we studied about VCR cycle, which is the refrigeration cycles, and we studied about refrigerants, different type of refrigerants, and later we studied about each and every kind of machines, especially non-centralized machine and centralized machines. And similarly, so why we studied these machines? Once this heat load is done, now beg your pardon. Now we studied about the heat load analysis by manual method, Excel method, HAP method, isn't it? So whatever, at the end of the day, as an engineer, you might have an idea to choose the machine wisely for your project. So that is the importance of studying this topic. Okay, clear? And later, once you completed this Excel sheet and this HAP software, once again, guys, HAP and Excel, it's not a parallel thing. It's two different things. If you are providing outputs, then you need to purely provide HAP outputs only. You don't need to attach any Excel outputs along with that. You can use Excel for your reference, but not for the client reference. Clear? Okay, so this is all about this one itself. Then once again, guys, later pardon, in tomorrow's session, tomorrow is Wednesday, isn't it? Yeah, tomorrow we will start up with the ducting, duct side aspects, such as to be the different type of ducts, the duct shapes, material, duct classification, simply. And once it's all done, we will be get over with the AutoCAD class. Okay, so probably we can start the AutoCAD, and we need to wind up our sessions more fast as we can. Okay, before at the end of the November itself. So this is our upcoming syllabus. So is there any doubts on this one? No, isn't it? So we can wind up or not, or we can jump off to the next session. Hello? What we need to do? We can wind up or we can continue.
Wind up and class, sir.
Okay,
Can
fine.
you
Okay.
go through all these?
Yeah, you need to make a small go through around this happen. So
Yes.
just combine this both classes. Okay, that means yesterday class and today's class, and go through in a fully revise it once again, then try with your laptops or systems. Okay. So, okay, guys, you can leave. Have a great day ahead. Bye.